So we will be doing the assembly and the working principle of the clutch of the ATC motorized bicycle engine. First of all, we'll be covering some stuff on bearings for you to be able to understand. In fact, that's a quick and rough video, but we will try to cover everything. But I'm going to do this very quickly, and it's not like a video that I'm taking time to make it. It's a quick video. So first of all, we need to try to understand that if I have a shaft here, there are two main forces that will act on this shaft, mainly the radial force and axial force. Radial thrust, axial thrust. So in any cases, I want to prevent those forces should cause no problem to my systems, should cause no problem on my shaft. Either the radial force or the axial force should cause no problem in my system. So this is why I put bearings, so as to reduce friction and prevent like any problem that those forces can cause. So normally I will have my main shaft there. I will have my ball in a bearing, and I'll have my ball bearing in a race, and I'll have my ball bearing out race. So those are the ball bearings inside. So definitely you can see that when the shaft turns, so this will be fitted on the shaft. So those two races can turn independently. So this reduces friction. So that's it. And a small thing that I can explain is that when this is the axial thrust, when the axial thrust is offset from the center, a moment is created. Similarly with the radial force. So our bearing reduces friction, and we try to minimize the force that the problems that the radial or axial thrust can cause. So for example, as you can clearly see here, I have this type of ball bearing. So this type of ball bearing, you have angular contact. You can clearly see here that this type of ball bearing kind of prevent axial thrust. So this is why we use this kind of. We will not do so many things on bearings, but to make you understand that. So as you can clearly see here, you'll see that the ball bearings are in a circular pocket separator. Furthermore, you may have like a radial contact bearing to reduce the effects of radial thrust and reduce friction. And as you can clearly see here, you may have those ball bearings in snap over separator. That's it. And you understand that the clearance between the ball bearings, one ball here, the clearance between the ball bearings, cater for thermal expansion, and so on. Furthermore, you have 4-point contact ball bearing. So 4-point contact ball bearing, they are used for radial thrust and axial thrust at the same time. So this is a quick review of ball bearings, and we'll see how this will be useful in the 80cc engine clutch. So basically we will try to explain like this part. So we'll try to explain this part, how ball bearings is useful in this assembly. So let's get to it. So we'll be explaining how all of those stuffs work, but now we are more concentrated on the ball bearings. So on the previous setup, I had that big bevel gear or big bevel wheel. That's a wheel. This wheel, don't forget, we'll talk about those later. This wheel is fitted onto this. This wheel is fitted onto this. You understand? So as you can clearly see here, this wheel, so from this end up to here, this wheel is fitted onto this. As you can clearly see here, they turn separately from each other. You understand? They turn separately from each other, as you can clearly see there. They turn separately from each other. So this is fitted onto this. In fact, my engine turned this bevel wheel, this bevel gear. My engine turned this. So this is fitted onto this. Okay. So how it is fitted? We actually use gears. So in fact, in here I'll be having the bearing outer race. And this will fit in here. I'll be having the bearing inner race, which is here. So I can show it on the diagram here. So those are separate parts, like the bearing outer race, that's here. The bearing outer race goes in here, and this is fitted onto that. That's the bearing inner race, and I'll be having ball bearings in between the outer race and the inner race. So those are the ball bearings. So that's it. In fact, I will not be able to see the bearings. It's inside. So this is the bevel gear. In fact, I have a ball bearing outer race, which is, I'm not able to see it here. I have a ball bearing outer race, and then I will be having ball bearings, and then after the ball bearings, this is the base. This base acts as it contains the ball bearing inner race. So this is how this is fitted onto that part. So that's it. This is my ball bearing. This is my big bevel wheel. So first of all, I'll be having an outer race here. Secondly, I'll be having the ball bearings there. And thirdly, I'll be having the clutch base, which act as the inner race. So those two turn separately. So the bevel wheel will turn separately with the inner race. So this can turn in any direction, this can turn in any direction. They are completely separated. They are separated by ball bearings here. So that's it. So that's it. So as I told you here, this is the clutch base, and it acts as clutch base inner race. This acts as a clutch base inner race. So that's it. So we'll now explain some stuffs on on washers. So what is the use of a washer? So I have a bolt here and I have a nut there. So for example, I have a bolt there, I have a nut there, and for example, this is a metal surface that I want to screw this on. So washers are used to distribute load. So definitely, when I will screw the nut in this bolt, this will exert a force on this metal sheet on the upper side, and will also exert a force on this metal sheet on the lower side. So I will use a ring, I will use a washer to distribute the force on the metal sheet. I will use a washer, I will use a ring to distribute the load on the metal sheet. So that's it. And we also have spring washers. So what is the use of a spring washer? The use of a spring washer is to prevent rotation. When, for example, I take this as example. When the nut is screwed on the bolt, I would not want that the nut start to do counter rotation or start being unscrewed with vibration and so on. So this is why we use spring washers. We use spring washers to prevent rotation of the nuts or bolts after installation due to vibrations and so on. So this is how a spring washer is installed. A spring washer is installed between any two surfaces that has a tendency to rotate. And that's it. So, but some good principle that we can try we can use is that the spring washer should be slightly out of alignment to exert tension. So we don't we don't want to compress the spring washer completely. It's like, don't exert like too much force. Follow the instruction, follow the torque value, and use the spring washer. Follow the torque value for optimum operation of the spring washer. Now I will go through the basic principle of the clutch assembly. So I will go through it. This is a general principle. We'll cover the details afterwards. Like for example, in this picture, I have the complete details of all of the parts and so on. So let's do it. Should understand that I will have a main shaft here. What are the particularities of the main shaft? The main shaft will have a big hole here. The main shaft will be threaded on this side, threaded on this side, and I will have two small holes for two flat keys to be placed in them. So a hole here, a flat key will enter here, a hole here, a flat key will enter here. So I will show this. So this is B is the main shaft. So that's the main shaft. The main shaft goes there. That's the main shaft. The main shaft, forget about all of those things. I will show you their use afterwards. So the main shaft will have a big hole in it in red. The main shaft will have a big hole in it in red. And basically, this is the sprocket that will turn the wheel. This is the sprocket that will turn the wheel. This is where we put the chain to turn the wheel. So I will show you how the sprocket is fitted on the main shaft. In fact, we will use the flat keys and so on to fit the sprocket on the main shaft. So first of all, let's look at the main shaft. So that's the main shaft. I don't have it dismantled completely, but you can check this on Bikeberry. They did a video on all of the parts like dismantled. So I will show it. I don't have it dismantled because we need to go to workshop and so on. So I'll try to explain it. So that's the main shaft. Forget about all of those things. You need to try to understand that's the main shaft. The main shaft is threaded on this side and threaded on this side. And I will be having two small holes or notch in which a flat keys will enter in those holes. So that's it. It's completely the same. Have the main shaft, have a bigger hole. You're not able to see it there. Have a bigger hole. You will not be able to see it. I will try to explain this. And this is where the sprocket will fit on. This is where the sprocket will fit on. So in general, it is like this. The main shaft, the big hole, threaded on both sides, with two holes in which flat key can enter those holes, and two things that you need to understand is that this side, the sprocket will fit onto this part, and this side, it is the clutch inner base that will fit onto this part. So we'll try to explain this. So the sprocket will enter this side, but as you can clearly see here, if I need to place this sprocket onto the main shaft, which is there, the thing is that the sprocket can turn. It will not be locked with the shaft, meaning that if the shaft turns, the sprocket will not turn. So the flat key is very important. The flat key will enter, as you can clearly see here, the flat key will enter this part, and the flat key will enter this part. The flat key, in fact, will lock the main shaft and the sprocket together, so that when the main shaft turns, the sprocket turns, and then when the sprocket turns, this will be able to turn the bicycle wheels. So the flat key is very, very important. The flat key will lock the sprocket and the main shaft together. So that's the flat key. That's the flat key. So as you can clearly see here, the sprocket is on the main shaft, but it can turn freely. So the flat key will lock the main shaft with the sprocket, so that when the main shaft turns, sprocket turns along with, and this will in turn turn my bicycle wheels. So the flat key is very important in this. So even the sprocket is locked with the main shaft, I will need a bolt. I will need a nut to secure the sprocket in its place. So this is why I'll be using an M14 nut. I'll be using an M14 nut together with a spring washer to lock this sprocket in place. So this will be, I will screw the nut on this, and I will be using the spring washer so that I can lock this sprocket in position, so that they will stay in place. The sprocket will not go out due to vibration and so on. So I'm simply using a nut and a washer to secure this sprocket in place. So that's it. Another thing I want to tell you is that if I want to remove the sprocket from the main shaft, what do I do? So this is in my bicycle. I'm actually seeing it as such. How do I remove the sprocket from the main shaft? So this is on my bicycle NG. The only thing that I'm able to see when removing all of those stuff, I'm able to see the sprocket at one side of the engine, at one side of the bicycle, and I'm able to see the friction plate on the other side of the bicycle. So if I want to remove all of those stuffs, I need first of all remove the sprocket. So how do we remove the sprocket? So this is very simple. First of all, the first step when removing the sprocket is, first of all, I need to remove that nut and washer. So as I already told you, to be able to secure the sprocket and the main shaft, I need to secure them with a nut and spring washer. So first of all, I'm going to remove the nut and spring washer, which is secured on the main shaft there. So then how do I remove the sprocket? Note that the sprocket is locked with the main shaft with the help of a flat key, and the flat key is not here, I'm only showing you. So the sprocket is locked with the main shaft with the help of the flat key. So if I want to remove the sprocket, I will need to use this tool. That's simple. So this tool has thread on the outer surface. I will screw this tool onto this. As you can clearly see here, I'm having thread on the inner layer and the inner layer here. I'm having thread here. I'm referring on this surface there. So I will take this, I will screw onto that. So that's the principle. I will take this, I will screw onto that part. So my sprocket and my tool is locked together. And then when I will screw this on, this will press on the main shaft. And when it will press on the main shaft, this will help me to remove the sprocket. You understand what is happening here? So this, I will screw it onto this sprocket. So the sprocket and the tool are fixed together. So when I will screw this, this will press on the main shaft. When it will press on the main shaft, the shaft will have the tendency to go downward. When the shaft will have the tendency to go downward, so I will be able to remove the sprocket from the main shaft. So this is how you remove the sprocket from the main shaft. In fact, it is on the bicycle. You take the tool and then you do it. So this is a quick recap on how the sprocket is placed. So I'll be having a hollow race on my main shaft. The main shaft will be threaded here. I'll have thread on this part here. So my sprocket will be locked with the main shaft with the use of flat key, which is here. The sprocket will fit into the main shaft and locked into that position with a flat key. And then I'll be using an M14 nut and a spring washer. The nut will be screwed on this threaded part here to secure the sprocket in place. So that's it. In fact, I'm actually using an internal tooth lock washer. An internal tooth lock washer has this side view, and which has radial teeth providing strut action. And the use of the internal tooth lock washer is that it absorbs shock and vibrations, and also will prevent unwanted rotations due to vibrations and so on. So usually the usage of internal lock washer, how it is used. So you have the bolt which is here, the nut which is here. You may have a flat washer, a ring, a flat washer which is here, and you will be having the internal lock washer which is here. So I already explained this part, so how the sprocket actually fits on the main shaft. And then on the other part, same thing occurs. But on this side, it is not the sprocket that is secured on the main shaft, but it's the clutch base inner race. So what's the clutch base inner race? This is what I'm trying to tell you. This is the clutch base inner race. As I previously said, you know that this and this are already fixed. That's a single part. I have this, and it will have the outer race, ball bearing, inner race. So this is a single part. So this part, which you see here, is actually fixed. This part here is actually fixed on the main shaft here, with the use of a flat key. And similarly, when this is fixed on the main shaft, this is locked on the main shaft with the use of a flat key, the clutch base inner race is secured into position by the use of a nut and a washer, similarly. So that's the thing that I'm actually explaining here. So on both sides of the main shaft, same thing happens, which means that this is the clutch inner race. The clutch inner race will be secured on the main shaft with the help of a flat key, and for the clutch inner race to hold in place, we'll be using a nut and a washer. So this is what I'm explaining here. This is the clutch in a base. You understand that the clutch in a base comes with the bevel gear. That's the clutch in a base comes with the bevel gear. So this is a single piece, but I'm only showing the clutch in a base here. So the clutch in a base will be locked with the main shaft with the use of a flat key. So the clutch in a base will be locked with the main shaft. So when the clutch in a base turns, the main shaft will turn. So I will hold the clutch in a base in position with the use of an M14 nut and spring washer. So similarly like this sprocket. So small recap. As I told you there, so the main shaft will be locked with the sprocket with the use of a flat key. So first of all, just forget all of those parts here. I will explain them later. Just remove them in your head because it's like in the middle. So just don't care about those parts here. So just understand that, as I already said, the main shaft will be locked with the sprocket with the use of a flat key. The main shaft, that's it here. The sprocket will be fitted onto the main shaft with the use of a flat key, and when the sprocket turns, the main shaft will turn because of the flat key that holds them together. To be able to hold the sprocket in place, I will use a nut and a washer. So that's it. Similarly there, when I'm having the clutch base in a race, so forget about those parts. I will explain those parts afterwards and forget about them. So just remove them. Understand that this clutch base in a race will be locked onto the main shaft with the use of a flat key. When the clutch base in a race will turn, the main shaft will also turn. But you need to try to understand that the clutch base in a race, the big bevel wheel and the bevel wheel, those are the same piece. So a small recap is that you understand that I'm having the bevel wheel, I'll be having the outer race. So this is the outer race. The outer race is here, and I'll be having the bearings, and this will fit onto the clutch in a base. And the clutch in a base will fit on to the main shaft and will locked into this position with the help of a flat key. And then to hold the clutch in a base in place, I'll be having a nut and a spring. So that's it. A simple thing that I will explain is that note that when the main shaft will enter, for example, when the main shaft will be fitted into my engine, it will be like in a hollow tube. So for example, that's my engine, and the main shaft, which is here, the main shaft. In fact, that's this one. When this will be fitted into my engine, when this will be fitted into the whole tube of my engine, I will definitely need bearings. I will put bearings here and here to hold the shaft in place, to reduce friction, and so on. So this is why I'll be having bearings here and there. So we are using bearings. So I will show you this on the diagram. I will show this on the diagram. So on the diagram, you can clearly see here we have two bearings. We have this bearing and this bearing. In fact, they will fit on this bearing and this bearing. They will fit on the main shaft, and as the shaft enters the whole tube on our engine. So that's an example, as you can clearly see. So I will need this bearing. So when I will place my shaft into that hollow tube, I will say that hollow tube of the engine, I will need bearings on both sides to support the shaft. This is why I have bearings on my diagram. So bearings here and ball bearings here. So two ball bearings that will support the main shaft. Generally, as I already said, so this whole system, this will be fitted on my engine. It's like on a hollow cylinder of my engine. This is why I say that the main shaft need to be supported by two bearings. So that's it. I don't have a printed engine plan, but I can show you. So that's it. So this is my engine. So the clutch assembly will be fitted in this hollow cylinder. So this is why I need the bearings to support the main shaft. So let's continue to our main working principle. So we'll be doing all of those stuffs afterwards. So as I already said, this sprocket is fitted onto the main shaft with a flat key. This is locked on the main shaft with a flat key. It is secured in place with a nut and spring washer. But now on this side, as I previously said, the clutch in a base bearing, is locked onto the main shaft with a flat key. So I will explain this in detail. I will show you how it is. So I will show you. So that's the whole piece, which includes the bevel gear and the inner clutch inner base. This is the clutch inner base. So as you can clearly see here at the back, when I turn the clutch inner base, this moves. So the bevel gear and the clutch inner base are completely separate, so they turn separately. So as you can clearly see here on the clutch inner base, I'll be having the small race for the flat key to enter here. So the clutch, it is the clutch inner base that will be locked on the main shaft. So the bevel gear will not be locked on the main shaft, but it is the clutch inner base that will be locked on the main shaft. So this is how it goes. So the whole piece, which includes the clutch inner base, the whole piece, mainly the clutch inner base, will be locked onto the main shaft with the use of a flat key, which is put in place. So and then this whole piece is secured in place by the use of a nut and washer. I will show you how it is done. So that's the main shaft. This will be locked onto the main shaft by the use of a flat key. So as you can clearly see here, this will be locked on the main shaft by the use of a flat key. So when I turn the clutch inner base, as the clutch inner base is locked on the main shaft, so as I turn the clutch inner base, the main shaft will move. Of course, here, as I'll repeat it again here, so this whole piece is secured on the main shaft by the use of a nut and spring washer. The nut and spring washer will be screwed on here. So I will take the spring washer, I will put it here. I will take the M14 nut and I will screw it on there. So this is how this whole piece, which includes the clutch inner base and the bevel gear, that's how this whole piece is secured on the main shaft. So logically, when you turn the clutch inner base, this will turn the main shaft. When you turn the clutch inner base, this will turn the main shaft. So this will turn the main shaft. When the main shaft turns, as the sprocket is already locked on the main shaft, the sprocket will turn, and this will turn the chain, and which will in turn turns the wheel. So that's it. Before proceeding, I will explain, like, for example, if you want to remove this from the bicycle. So what do we do? As I told you here, that's the main shaft. So forget about this for now. That's the main shaft, and to secure this whole piece on the main shaft, I'll take a spring washer and an M40 nut. I will screw it on here. I'll screw it on here, so this will secure the whole piece on the main shaft. But now we are also provided with threaded part here. As you can clearly see here, a threaded part there, in a threaded part here. So this is used to remove the whole piece from the bicycle. So again, that's the same principle. We need to use this tool. This tool will have thread on its outer surface. I will take this tool, I will screw it onto there. I will screw it here. And what will happen? I will screw it till it's tight. And the next thing is, like, when I will be screwing this bolt, so definitely when I will screw the tool onto this tight, will be like this tool, this part will be like this part will be like fixed with this part. It's like it will be fixed with the clutch in a base, noting that the clutch in a base and the bevel gear are the same thing. So I will cut short and I will simply say the bevel gear as a whole piece. So when I will be screwing the tool onto that tight, it's like this bevel gear, the whole thing, the whole piece, and this tool will be tight together. They will be like they will be closely held with each other. So when I will turn this screw, this will have a tendency to push on the main shaft. When it will push on the main shaft, the whole piece will then move out. So that's the same thing here. Same way we use this tool to either remove the sprocket or remove the bevel gear, the whole piece of the bevel gear and the clutch in a base. So that's it.